next session is about the vertical view on 6G. We have some interesting speakers. I would like to ask everybody to type their questions in the Q&A box, and I will try to reflect all the questions to the various speakers. We will start the session by the initial presentation of the speakers, and then at the end we will have the question and answer time session for the speakers of this session. So I would like to introduce the first speaker, Marius Spica from Volkswagen. And I would like to say that Dr. Marius Spica is the head of the digital architecture concepts at Volkswagen Group Innovation. And his role is related to the enabling technologies and communication solutions for future mobility services, and has a wide expertise and involvement in topics related to the automotive domain, data-driven functions, driver assistance systems. So I think we will have an interesting feedback from Marius. So I give the floor to the first speaker. I stop sharing, and I think Marius, you can use.
Yeah. So thank you very much. I will try sharing my screen. Do you, well, let me, can you see it already? And can you hear me?
Yes.
Very good.
Perfect.
Okay. Yeah. So I'm a speaker from Volkswagen Group Innovation, as Nancy just told. The Group Innovation is more or less the research department for Volkswagen and the Volkswagen brands. And so as you might know, Volkswagen is a big car company. So we are delivering more or less 10 million vehicles per year. And now the big development is now we are going to become or to launch more and more electric vehicles. And also in parallel, we are becoming more and more a software company. And as we are a software company, of course, there will be more innovative functions that rely on connectivity, on software, on cloud computing, and so on. And this leads now to one of the challenging use cases that we see for the future, and that would work when we would have better connectivity. And this is the automated driving. And the automated driving, as we try to use it today, works only in the car. So it is somehow not connected. So this means here you see the vehicle, here you see the surrounding, maybe some objects or whatever. And all these objects, all the environment is being sensed by sensors that are in the vehicle. And then when we have this information, this data, then the magic happens in the vehicle. So here is the compute power. We compute, we interpret what we have seen in the surrounding, and then we derive some how the vehicle should behave, how it should act, if it should brake or take overtake or whatever. So this is how we do it today. But what we see for the future as a vision, that we might be able to shift this compute power more to the back end. And this is shown here. So we would, if the networks and the clouds, the data centers would allow this, then we would use some sensors in the vehicle as we did it now. But then we would like to shift this compute power from the vehicle to the cloud. This is done because when we do this, then we are much more flexible, because then we can then it's easier to adapt or to update the functions in the back end. So we don't rely anymore on our vehicle cycles that are several years. And this would ease many things. And so this would mean we sense everything, we get the data here, Then we have to transfer the data via the communication channel to the cloud. Then we calculate, for instance, the trajectory. This means so how the vehicle, where the vehicle should go within the next millisecond, and then this information is being transferred back to the vehicle, and then the vehicle again control or takes care of the control. And what are the consequences then when we would use this connection? Of course, when there's no coverage, when we lose connection, then the automated driving function would not exist anymore. So the vehicle would have to, we would have to find a fallback solution what to do in this case. Then also there's the reliability. We need, in order to be reliable somehow, we need to predict the communication or the service quality in order to allow a graceful service degradation. This means, so maybe when we know how it behaves, how the communication will behave in the future, then we could allow the vehicle to start maybe to reduce the functions that are possible. For instance, not allowing overtaking, or I don't know, slowing down. Then one consequence is the something that is different than today, because it's the data throughput. We need a higher upload than the download. So, and this is really in contrast to this, what we see today in today's commercial systems, because we need to transfer the data. This is also some video data and so on. We need to transfer this to the backend, and the download part is much lower than the upload. And also the latency, this is something that is important, because when we compare it to a computation within the vehicle, of course, in this on the backend or communication side, we have to add the upload time, the computing time in the backend, which we assume that is lower here due to the bigger computation environment, and the download type. If we add all three of them, they have to be lower than the vehicle the computing time that has happened before only in the vehicle. Yeah, and so the expectations of 6G are firstly the coverage. So we see something, maybe we need some multi-channel connection, something like a dual SIM, dual active possibility. We also think that there must exist a multi-technology like a cellular and satellite as a redundancy channel for this use case. We need reliability. This means predictive quality of service in order to allow the system to adjust everything to the predicted quality when the quality will go down, for instance. Also here, the dual SIM, dual active. We also need a continuous information about the cell status in order to adapt the system to it. And then also here, once again, the data throughput part, dual SIM, dual active. And we also think that we need some additional frequencies in order to allow this high data throughput that we have, the high upload that we have to achieve. And the latency, of course, there might be the need, or we believe that there is the need of edge computing. So we have to bring the compute power closer to the vehicle. It's not enough to have a data center, for instance, only in the northern part of Europe, and to communicate all the data so far. And yeah, so these are, in very short, the requirements or the expectations we see for the next generation of communication technologies.
So thank you very much, Marius. We will wait for questions in the Q&A button. I will pass to the next speaker, Antonio Fernandez Barciela. Antonio is a Car2X expert at Stellantis. He has been working in the R&D department of PSA for connectivity projects, and he's the working group 5 chair in 5G AA, and working in several international and national innovation projects like 5G Croco and others, where he has undertaken several roles, like leading roles or contributor roles. He has a wide expertise, I think, in the area as well, and we are looking forward to the presentation. Antonio, the floor is yours.
Yeah, do you hear me?
Perfectly.
And you see my screen too, yeah?
Yes, everything is okay.
Okay, very well. Thank you, Nancy, for the introduction. So, well, first of all, I come on behalf of Stellantis. Some of you may be not aware, yeah, we're a really young company born this year, early in 2021, thanks to the merge of ex-PSA and ex-FCA with an important worldwide footprint and a rich set of brands. Well, what I have prepared is just the 3-minute slides. One is what's our vision of what is the V2X communication, what we think it is. Yeah? Then we'll talk a little bit about, well, what is our wish list for the future. Yeah? And finally, we have a look at what we have done in the past and how we should do what we should do in the future, aiming at 6G. So first of all, in the V2X perimeter, maybe one of the things we normally have every single time we talk about this, V2X, and there is a lot of documentation, there are a lot of elements, and indeed, normally there is a simplification that maybe is just linked to the lower part of the image, yeah, which are the communications of V2V, V2I, V2P, which are purely or maybe strictly linked to ITS communications. Yeah, those yellow use cases, they were normally linked to safety, and for sure that are a crucial element for autonomous driving. Yeah, connectivity coming as a off-board element. But we think we should go beyond. Yeah. So what do we mean by that? Well, in V2X there is not only this ITS part, which is relevant and important, but we should also highlight some of the use cases that come linked to the part of the cloud, yeah, where we put here the ICT world, because, well, depending on the company, depending on the way it is organized, but it doesn't matter. Finally, you're taking into account elements that comes from the IT world, and we put here some of the V2X use cases. Okay, vehicle to network generically. We are putting vehicle to cloud to be more precise. If we think about the paradigm of the extended vehicles, what's the vision of the OEM? No longer having just a piece of metal going on the road. There is always part of the cloud is common with it. So this is a crucial development. Then vehicle to device, because we do react with the user, and today the user, the driver, the passenger, the way of identifying is linked to its smartphone. And finally, we're also putting here the vehicle to factory, because indeed, well, the vehicle will communicate with the factory for software updates for whatever reason it is. And we have highlighted quite a few use cases that are linked to this. And finally, we also put here everything that is linked to the electrical vehicle, something that my colleague has just evoked. We are ramping up into the market. You're all aware of this. And in the V2G, there are quite a few use cases that come in linked to this. So when we talk about the automotive and our interest in the communication, we would like to keep in mind, this is something we also repeat a lot when we're talking into 5G. The interest of the OEM is not only for autonomous driving, okay? There are other use cases, other things that are also interesting, and that help us to get a broadened audience to got, let's say, much more customers. When I say about customers, talking in the sense of use cases, and in the cars we're enabling up to equip and to use the communication. Okay, so just that as a brief introduction in what we think it is V2X. Then, okay, having that in mind, what do we want to get? What's our wish list going beyond 5G? Okay, so we just say beyond 5G in order to help to. We do not know exactly when 6G is going to be enabled in terms of release or whatever it is. But finally, 5G is today the present. So what do we want to get beyond that? And well, it's clear. It was interesting to see the demo just before the conf call we were doing. So it's clear that in terms of positioning, there are expectations, and it was nice to see the demo providing using for that. It's also really important to really get an overall vision of the spectrum. I think today, as OEMs, or let's say if you take a vehicle, we still have to manage the different technologies that are available, the different routing that we need to do in order to choose them. Well, it would be good that there's an overall 6G can help to really have a global umbrella providing the vision of license and unlicensed spectrum. And let's say then I don't have to be aware of it. I just use it, and it's provided as a service in the way that it works in any situation, providing the best thing at every moment. It was also very good to see just in the presentation from our colleagues from Volkswagen, the fact of the end-to-end latency. Definitely, this is something I think it has been an obsession for 5G. Okay, we want to get into the RAN in the radio access network, something like 1 millisecond. But finally, I don't know if we have to put so much pressure into the RAN, because this is an end-to-end thing. So we really have to pay attention to the overall chain that we're using in the communication. So it's not only pushing forward the RAN, we really have to pay attention to all the elements that are involved. Then other elements that we would like to see in the future is linked to SafeLink, which is something that has arrived with 5G, but we definitely think it will stay in the communication optional solutions that are available. And some power savings and the way we use the communication between devices to go further, to go beyond, should also be explored. And in the usage of the cloud, which is linked also to the fact we were saying before, to the end-to-end vision, and it was also something that the previous speaker explained very well, in the sense that it is useful to get used or to serve from the different elements we're going to get from off-board, outside the vehicle. We really want in the future to use them. And one of the examples of different services is artificial intelligence as a service. That could be one of the things that we will be able to really use as an example, by getting a distributed federated learning. But it's just one of the examples, one of the options, or one of the features that come with the usage of off-board cloud that really has a reliable communication next to the vehicle. And finally, I think it's really important also, we always see in each new generation, communication generation, there's always the chicken and egg problem. Who's going to deploy first? Is the infrastructure that needs to arrive, or we need customers or UEs equipped in order to get a volume that it makes worth the deployment? So we do hope that with 6G, the paradigm is going to evolve, not only in a technical perspective, but also in a business or in the strategy we use. So we should no longer talk about the exchange or the way we define the services based on paying by gigabyte or, I don't know, megabyte or whatever, but much more to have a full vision of pay per service, depending on what I exchange, what are my requirements, and not linked to the quantity. So forgetting maybe a little bit the current paradigm that we have, or I'm not saying forgetting, but evolving this paradigm into something that it has a different vision, as I have just explained. Okay, this is our wish list. And to end with my part, we have been, or Stellantis, really active in 5G, and I think it's important to say that we were not so active in 4G, because really with 5G, there was the first new generation where the automotive was taken into account from the very beginning. And it's clear for me that it's going to be exactly the same towards the future. So for 6G, it's going to be the same situation. And there is no way of doing this on a silo perspective. We do have to keep going on our open innovation strategy. I think also it was already evoked in the introduction. I belong to actively to the 5G AA ecosystem, let's say. I think it's a useful example of how the different worlds shall work together. And well, I think this is also a very good initiative, this 6G summit. Yeah, we really need to work together. We cannot do it on our own, and the way we define 6G has to be like what it has been done in 5G. Yeah? Defining the new enablers linked to what are the expectations of the future customers. And one of them for sure is going to be the automotive. So with this, that's all on my side. For sure, I'm fully available for any question you may arise, Nancy. The floor is yours again.
Thank you very much. I think I expect to have some questions. I already have received offline some questions. So, but let's try to handle the questions at the end. So the next speaker is Christoph Tümler. Christoph is a founding member for 5G Health Association. He's director in the Center of Care of the Elderly in Leipzig area. And he's specialist for general internal medicine, geriatric medicine, emergency medicine. And he has a wide expertise in industry consulting as experience, and also participation in several projects, R&D projects involved in SME startups and spin-out experience. So I think we can have a very interesting, let's say, discussion and presentation from Christoph from the health sector. Thank you. The floor is yours.
Yeah, thank you very much. I try to share my screen, see that that works. Okay, so let's see. I don't know, can you see it?
Yes, yes, we can see it.
Perfect. Yeah, Antonio said already so much about 5G and 6G, and actually, to be honest with you, most of my talk, at least when it comes to the general bits, I could just say, already said, you know, Antonio said it already, but let me just carry the ideas of the Automotive Association and the automotive industry a little bit into the health domain. I mean, as you all know, the health domain, if compared with automotive, we are still, when it comes to 5G and 6G, in the Stone Age. So we are starting slowly, but moving on steady. Let me start basically to say, I would like to look a little bit on the new network side, meaning 4G, 5G, 6G, and what it means for the health industry. And when I say health industry, I mean in particular the hospitals, the healthcare providers, but also the medical technology industry, and up to a certain degree also the pharmaceutical industry, because we will all see in these areas some kind of industry 4.0 effects, meaning soft factors. To say it a little bit with Tom Peters, you know, soft factors will become the hard factors, and the hard factors, they will turn to soft factors. So talking about, for example, medical devices like infusion pumps, they were important as mechanical bits and pieces over the last century. But now we are looking at an increasing trend that the industries, they're saying, okay, we're manufacturing infusion pumps, we're manufacturing ECG machines, but what we actually want to sell are services in a kind of new age that support these devices wherever, whenever. And I want to start telling you a little bit about a project I'm involved with, Helios. That is where I work as a doctor, as a physician. So we just were completing a 5G project here in Leipzig. So we were implementing a standalone solution, a private 5G network on campus. So if you want, we are one of the first clinical campus networks, standalone clinical campus networks in Europe. And it is a very rewarding project. We get a lot of ideas and insight, which I talk a little bit later on. So basically, our aim was to build this network environment, to build this test bed for other industries, then to use it for testing of devices, smart pharmaceuticals, and so forth. And we did all the work, I mean, it's a relatively big place, so we have almost 1,000 hospital beds in a campus solution in Leipzig, in Germany. And we got the frequency from the Bundesnetzagentur, is our national regulator. You know that in Germany we have allocated frequencies for private 5G networks. So we got a frequency, a local frequency that we can use for our own purposes. We have indoor and outdoor coverage, and we implemented this 5G core to start seeing what kind of benefits we might be able to experience from that. Because in the industry, in the health industry, there is a lot of criticism about these new technologies, 5G, 6G, and so on. So we are still on a level 2000 or something like that. Everybody is happy to have Wi-Fi 5. Good. And this is something which is a problem, definitely. So we need to move forward because, of course, there are challenges. The pandemic, everybody is aware of the challenges that were associated with the pandemic and with the technology that we have in place. We are not remotely, we are not in the position to handle that. And the same accounts if you think about of crisis situations and so forth. The current network infrastructures, they are not in no way perfect to deal with these kind of things. So just a little picture of this is one, you can only see one side of the hospital there. To the left, you see the Leipzig Heart Center, which is a very modern heart center in Europe. On the right, you see my hospital, the Parklinikum, where I work. And we have on this building 2 5G rooftop antennas, and we have 38 indoor hotspots. It's a Huawei core that we're running, and Telefonica installed that thing. This is a kind of aerial, so basically you can see here in where it says Park Krankenhaus and Helios Parklinikum and so on. This is where the heart center is, where this is just a picture that you saw. And when you go a little bit further down to the right, you see the Leipzig Südost. This is a psychiatric hospital. And in between you have labs, you have all kinds of facilities, you have some emergency services located and so on. You can see it makes completely sense to drive solutions for such a campus. Let me see. So this gives you an idea about the architecture that we used to run there. This is what we want to do. A lot of challenges, obviously, that are still part of this, because I mean, we have decided to implement 5G and Wi-Fi 6 exactly for the reason that, and this is what I envisage a little bit already for 6G. You can see we have Wi-Fi 6 and we have 5G because we were saying on the one hand, okay, we need redundancy systems. But on the other hand, we made the experiences that the promises of the 5G releases, release 15, 16, when it comes to positioning, that these promises, they are not true. So we cannot do device detection inside a hospital with 1 meter accuracy without some kind of additional system. This is simply in an indoor scenario impossible, and we need to find solutions. And my ideas and my hopes is that with 6G, we can have basically some kind of integrated chipsets that actually contain further frequencies apart from that main carrier frequency. So there was talk about terahertz, there was talk about sub-terahertz, and all of these kind of things. They might help us to have alternative frequencies for alternative tasks in place. And the use cases that we are targeting in the moment, and that I think would be of interest in the health domain, is, for example, use cases like connected infusion pumps. And we are speaking to the manufacturers of these pumps, and they already said, yeah, you're absolutely right. We know that we have to do that. We know that we need to fit the pumps with additional technology to function as nodes or hotspots, or whatever you want to call that, to establish networks like in a fog architecture, where you have small networks around the patients in their beds, and networks that recognize other devices that are allocated to the patients. And each of these pumps should be able to function as a gateway. So in other words, you know, it would be good if these pumps had multiple connectivity options. So not only 5G and 4G, but more, you know. And also, and I totally agree with what was said before from Marius and also Antonio, we need a proper upload, you know, so there is data coming then from the network, which is going to be a more intelligent network. And this does not mean download only, all the other way around, you know, because especially if you look at cardiac devices, connected cardiac devices, these are basically, they're all streaming in real-time cardiac data. And if you want to process that, then the amounts of data are getting higher and higher, depending on the resolution. Yeah, and good applications like patient flow monitoring that also requires intelligence in the network. I don't know if we really have to stream all this data to some kind of data spot somewhere. I don't know, in a centralized area. I don't think this is a good idea. I think we should try to resolve as many issues as we can local, and only if we have computation problems that enhance the local capability, we should try to access data centers that are further away. So I think this is very important. Basically means we have to have more edge cloud capacity, and we have to have also probably edge cloud capacity in small fog nodes around the patients. And we need object flow management, and that comes to positioning, and positioning is unsatisfactory under 5G. And I don't know if we can really solve it with release 17, 18, maybe 19, yeah. But at some point, we all know that there will be no release 5G something anymore, but we will switch to 6G. So I believe that a real location issue will only be solved in 6G. And then, of course, all of these things where you really need very small latencies, when you want to remotely manage emergency cases, where you need sound, vision, enhanced, augmented reality, and all of these kind of things. We need more than 5G can deliver at the moment. And we need also a seamless backup of everything that happens, at least we in the health domain, you know, because we have a duty to document. And these were use cases that we were considering, and we're working with them in the current setup. And now I don't want to talk about this 5G stuff so much, because we have actually taken the step to implement the 6G Health Institute here in Leipzig, which is also funded by the state of Saxony, will probably be going live finally in April. We are still in the preparation process, but I think it's a very important institute, and we are working already closely together with some medical technology manufacturers, pacemakers, infusion pumps, cardiac devices, and so forth. Also with smart pharmaceuticals, inhalers, Boehringer Ingelheim, and I think this is badly needed, you know, because we need to make progress in this. In these scenarios, because these scenarios are still running as mechanical scenarios, unconnected. Imagine, you know, we tried to get any medical device with a 5G connectivity that we wanted to build into our network for demonstration purposes. We couldn't find one, not in Germany, not in America, nowhere. There is no medical device with any 5G connectivity. And I think that probably healthcare will more or less skip 5G connectivity and move to 6G straight away. So basically, we collaborate with different industries. We get funding from the government, but we also funding from third parties like industries, because this is meant to be, of course, some kind of network that we're forming. And we will be focusing on technologies from technology readiness level 3 to 4 onwards up to 8 or 9. And then for the industries to pick up on that and then sell that product out. The challenges I mentioned earlier on already, I don't want to talk about that too much. We maybe can have a discussion later on. but we need desperately to get started on 6G standardization. You might think I'm a little bit pessimistic, but I don't want to go into 5G standardization. First of all, we have already shown so many releases. And then, you know, I believe in the health domain, because we're running on a low pace, we have to go straight into 6G standardization in order to get ready for whatever comes up in 2026, 7, 8, or whatsoever. And you can see the 6G Health Institute. This is roughly the space. If you look on the left side, you know, you see these technology readiness levels, and we see the funding, you know, on the y-axis, and you can see already that we are focusing more, not so much on blue sky research. I think that would be too much. But now that the ideas of 6G are born, and we have seen already interesting demonstrations today, I think this is the time now where we can really get something going for the health industry and the medical device industry, which we will. And you see, this is the mission, you know, as I described it. We're going to go into gap analysis, because first of all, we need to see, okay, what is there already? What is there in 5G? What is there in 4G? What is there in Wi-Fi? So what is it that we are expecting from 6G? We need to formulate requirements. We need to think about prototyping, early prototyping. We definitely have to discuss 6G standardization globally in health, because the problem is the further we evolve, the more the network technology and the vertical technology merge. And so we have to think about, what does that actually mean, standardization? It cannot not only be 3GPP, that is for sure. We have to basically move on with these things relatively quickly. All right. Oops. These are figures that are quite impressive. I just put them on the slide. That means you can see how the evolution from 2G to 5G went. And now the question, as I said, is what is it that the health domain actually wants from 6G? And we have to work on this very quickly over the next 12, 18 months with the manufacturers and say, okay, guys, what is it that you really want? Because this is important for the whole standardization. And you can see there's clear evidence. You're all familiar with the Cisco reports and so on. And you can see that the machine-to-machine domain is growing. And this is exactly where I would like to focus on. Not so much these heavy use cases, you know, with robotics and with big video files and remote operating. I know this is all important and so on, you know, but I think from an economic perspective, there is really the business cases for massive IoT, which 5G cannot manage sufficiently. This is clear, we saw that already. And this is actually what we want to address, because I know that in the next 10, 20 years, more and more people have to be treated in their homes, outside the hospital. We don't have these capacities anymore. This goes together with the demographic development, and we need to connect these devices remotely. We need to connect the devices that are handed out to people. We have more and more implants and all of these things, and we have no solutions whatsoever how we can actually connect these devices to guarantee that they work properly, yeah, because this is one of the big challenges. And you can see that connected health, many people believe, every fifth, believes that connected health is really one of the killer applications of the future. I'm absolutely sure of that. And you can see that there was a Delphi study, and they asked people, you know, about disruptive technology, you know, and what do you think 5G will disrupt and so on. And I think, you know, 20% believe that healthcare will be disrupted. I don't know how many people from the health domain were questioned, you know, so it's very difficult to see, but it's a significant share of people that believe that 5G is making changes. And I believe what they actually want to say is not, I believe that 5G will disrupt the health vertical, but what they're saying is, I believe that new networks, which in my opinion is more 6G rather than 5G, that new networks, they will disrupt the health industry. And of course they will. And this is just an overview of the activities that we're planning with the 6G Health Institute. We will be looking into different streams. We will be looking into social technological alignment, because one of the big challenges is, you know, that the technology is moving on with a high speed. And we are now talking about 6G. We have not even 5G implemented the right way and so on. And you all know that people are not happy with this development. You know, there is more and more conspiracy theories. Think of these theories with COVID and 5G and Bill Gates and the chips. Yeah, this is all nonsense. However, it's there. And I believe it is, whatever research we're doing, we have to do something to basically take the people along, explain what we're doing, explain where we're going, explain what we're doing, that there are no health risks and so forth. So for now, I think this is what I wanted to say, and I thank you for your attention.
Thank you so much, Christoph. Very interesting presentation. I think we will discuss it a bit later. And then I would like to introduce the next speaker, Andreas Müller. Andreas is the head of the Communication and Network Technologies in the Corporate Research Department of Robert Bosch in Stuttgart, Germany. And he's very active also in the area of the communication technologies for the IoT. He is for the Bosch, he's the chief expert for this area. And he is coordinating the industrial 5G activities of Bosch across the different business units and plants. He is also serving as general chair of the 5G Alliance for Connected Industries and Automation, which is a globally leading initiative for driving the industrial 5G. So I think, Andreas, we are eager to hear your speech. I give you the floor. You can share your screen.
All right. Yeah. Thank you very much, Nancy, for the brief introduction, and thanks for having me. It's really a pleasure to be part of that interesting event here. Just let me bring up the slides. And I just noticed I have to maybe replace my background picture here and replace the 5G with the 6G when giving these talks. But it's maybe the usual transition phase. Right?
It's a 5G plus.
5G plus, yeah. No, I have the pleasure to also talk about 6G, of course, and to share a little bit my view on 6G. And I will not go too much into detail, right, but more have the general picture in mind. And also I have to disappoint everybody who is expecting some very concrete requirements in terms of higher data rates and lower latencies and so on. So there are certainly cases for this, but from my perspective, this is not the main thing that should be considered for 6G. It's more other aspects, and that will hopefully become clear during the next 15 minutes or so. So before talking about 6G, I always want to briefly talk about 5G basically and check where we are on the 5G journey. So Christoph also had this slide that he showed with the what people thought, how disruptive 5G might be for different verticals. We have seen it, I think it was from 2019, with automotive being the most relevant one, and then healthcare, as we have heard, was just mentioned by 20%. What I want to say here is that there was a big vision, of course, with 5G. And just took one picture here from Etsy, published in 2018, so which also outlined this vision a little bit, right? It was that 5G will basically have an impact on our everyday's life, will support all the different vertical applications, be it healthcare, be it self-driving cars, industrial automation, augmented reality, and so on. So that's the big vision that we had with 5G already. But if we check where we are today, it's more looks like this, right? So it's 5G is a reality. We have 5G networks, we have 5G chipsets, modules, handsets. But the main application basically still is the one that we are used to, so connecting mobile phones. And of course, the question is then, okay, why is it like this? So was 5G basically just overhyped? And is there then a risk that the same will be the case for 6G as well? And the good news is that there are good reasons why it is like this, right? So it's the consumer world, of course, with the smartphone, it's more the evolutionary development and all these new vertical applications, be it in manufacturing, be it in automotive, be it in healthcare and so on. These are more revolutionary because there is no real track record in using mobile communications in these domains. And also the verticals, they started basically late looking into 5G. So first of all, you have to establish a basic understanding of what this can do for you. You have to come up with a vision. Also the know-how basically related to 5G is very limited in many of these vertical domains. So that simply takes time to build this up. Also then many features that really make a difference to the vertical industries are still missing. So it starts to get interesting with release 16, and then with the further releases 17 and Infusion and also 18, there is more and more interesting things coming that really make a difference to the vertical industries. For example, ultra reliable low latency communication or support for time sensitive networking. So we have to wait for that. And once we have that, then there are many more things that we can do with 5G. And also this makes it then more attractive. But it's not just about a use case. At the end, what matters is a business case. Because if we're talking about vertical industries, we are talking about B2B business, not about B2C, where mobile industry is coming from. That means the only thing basically that matters in the end is a positive return on invest. And that means we also have to think more about how to find really the right business cases. And this is not as trivial as finding a use case. So that depends then on the pricing model and so on. And also this is something where the entire ecosystem, first of all, has to get together somehow and find a sweet spot that is attractive enough for everyone. Also, the device ecosystem is still missing in many cases. Manufacturing, for example, right? You can build up a 5G network in a factory, okay. But then if you want to connect your production lines and so on, so then it's much more difficult because the device ecosystem is not there yet. There are now some routers available and so on, which is already good because you can connect a router to all kinds of devices. But also here, it starts to get really interesting if we have automated guided vehicles, if we have robots, if we have tools and so on that come with 5G connectivity out of the box. So also this takes time. And at the end of the day, it's more than just the KPIs, the better performance that 5G can offer. What we need is new operating models. The private networks, of course, play a crucial role in many different verticals, including manufacturing. And also this comes along with changes then in the ecosystem, business models, and also here, this simply takes time. So I think these are really all very valid reasons why we are not there yet with the full 5G vision that I've outlined here. But personally, I'm very confident that we will get to that point. But I think when talking about 6G, that's always important to understand, right? So 5G is a reality, but 5G is not somehow complete or closed yet. So the developments are going on. We have 5G Advanced now coming up and so on. And it simply takes some time until we really see the full 5G vision become a reality. That means we should not stop working on 5G, thinking about 5G. But of course, at the same time, we also have to spend some first thoughts about 6G and so on, because the activities in general are taking off right now. Okay, so but what about 6G now? So what's in 6G for verticals? And that's now my general picture basically of 6G. What really makes a difference here compared to the previous generations. Now with 1G to 4G, as I already mentioned, it was basically all about connecting phones in one way or the other, connecting people, and it was basically all about connectivity. So a mobile system offered you connectivity for connecting mobile phones in general, right? And this is basically more an infrastructure as a service like model. That means there is someone building up the infrastructure, a mobile network operator. We pay the mobile network operator, and for that we can use the infrastructure for our phone calls or for accessing the internet and so on. Now with 5G, there was already a major paradigm shift because 5G is not just about connecting phones, but of course about connecting all kinds of things in the Internet of Things, all about vertical industries. The connectivity got better to support these new applications. I mentioned this, especially starting with release 16. There's a lot of things in 5G. But on top of this, there's a new layer coming in, which is a computing layer, right? So we have edge computing being an integral part of a mobile network. And this allows us to do things beyond just connecting things, right? We can start offloading intelligence from a device to the edge cloud, closing control loops over the air and so on. So this allows you really to change also the system architectures to support distributed systems in a better way. That's already very good. But the basic model is basically still an infrastructure as a service approach. Some players maybe would like to see it differently, but if we are honest today, it is still like this. And the question now, of course, is what is new with 6G? And we are having many discussions also internally within Bosch, and people then say, okay, if everything is connected, what can come next? So there is nothing else that can be connected. And that's true. And that's why I said also at the beginning, it's basically not primarily about better quality of service, what we can achieve, and so on. So that certainly has also a place in these discussions, but this is more than this. So from my perspective, there are really two major changes now that make a difference here. And these are the two new layers that you can see. So it's a sensing layer, so that we have these integrated sensing capabilities in the same technology stack in the network infrastructure or the end devices, that we can have radar integrated, that we can have imaging and so on. Because suddenly you can unlock additional value with the very same infrastructure, right? So in some cases you have maybe a network anyway, or you need a network in a factory or in a building and so on. And if you can use the very same infrastructure for getting information about the environment, context information and so on, so then you can increase the value add and this way get a better return on invest. And the second thing that certainly makes a difference is the intelligence offered by the network, so the intelligence layer here, that we support artificial intelligence, machine learning, basically out of the box, and that the things become intelligent things, which are then orchestrated and supported by the infrastructure. And of course, this also is then a potential enabler. So we just have to see if it really comes like this. But 6G will not be the classical infrastructure as a service model, but more everything as a service, right? Offering platform services that you can use for connecting your things, that you don't have to realize everything over the top and yourself, but there are many things that you can rely on to really simply deploy and also develop distributed applications in different vertical domains. So that's one perspective. There's another one I would like to highlight here. This is more about deployment models and also the spectrum, which has also been mentioned in previous talks already. So with 1G and 4G, it was basically always sub 6 gigahertz what we had. And basically it was a very homogeneous network. And of course, basically only the public networks that we had, terrestrial public networks. This is what 1G to 4G was all about in the sub 6 gigahertz range. With 5G also here, we already have some major change. So suddenly we got the private networks, the non-public networks, right? And this is a shift now from the public networks, which are very MNO-centric, classical B2C business model, to the private networks, which suddenly are enterprise-centric. So they are there, of course, to support connectivity in an enterprise context, in a factory, on a farm, in a hospital, or whatever. And this comes along also with changes then in the infrastructure, right? We need new interfaces to integrate this into the enterprise IT infrastructure, for example. Also, the scalability doesn't have to be as high as for the public networks. It means the equipment might become cheaper to some extent, and for complexity, ease of use is in general very important, because not necessarily a big team is taking care of this. So that's why we already have a major shift here. And at the same time, we have the trend towards higher frequencies, millimeter waves coming in. And of course, this makes particularly sense for these more local networks and private networks here. And again, the question is now, okay, what comes next with 6G? And basically, there are two things I would like to highlight here, or three things. Of course, we will keep what we had before. So the private networks certainly will play a very important role from the very beginning. In addition to that, we get then a stronger focus on the non-terrestrial networks to really have global coverage. But there's also another trend I would see here to really have even smaller networks, highly localized networks, smaller than a private network in a factory, so which can be maybe inside a car, which can be a machine tool inside a factory, or maybe even a body area network or something like this, right? And this is then getting not necessarily enterprise-centric anymore, but really becoming use case-centric. And at the same time, we have heard this before, we have, of course, the developments towards even higher frequencies, optical wireless, and so on. And again, these technologies make especially sense in these very localized settings, private networks, and the even use case-centric networks here. And the third aspect I would like to highlight, and I think I have to speed up already, is then the realization of the infrastructure. So where we're coming from is this here, basically rather closed systems, proprietary hardware, proprietary software for both the RAN and the core, which lead to also high lock-in. With 5G, we already have a change here. So typically the core networks are already fully virtualized. The RAN is more still in the traditional shape. And with 6G, from my perspective, this development towards softwareization, virtualization of the complete infrastructure has to continue and will continue. And of course, Open RAN is here a key topic, so that the entire infrastructure is virtualized, which allows us to easily adjust it, to adapt it to different applications. And that's very important for the verticals because it's very heterogeneous, right? It's not just one network to serve them all. Even in manufacturing, it depends on the type of production, what you're considering, what an optimal infrastructure should look like, and so on. So therefore, this flexibility and adaptability is very important, and Open RAN promises at least to achieve much of this. But of course, it also still needs to be verified and validated. There are also some open research challenges certainly here. But from my perspective, it should be considered from the very beginning that this is more becoming the standard deployment model. And also the open APIs then, which allow you to easily tailor it using XApps, RApps, for example, and also to easily integrate it into an enterprise IT infrastructure. So of course, many of the things that are currently being discussed in the 6G environment are not really new, right? So these are some building blocks. We also referred about it before. It's of course better wireless connectivity, better performance, but also things like edge computing, digital twins, distributed AI. So every aspect by itself basically is not really new, but I think a really new thing about 6G is that it will be consistently integrated into a single platform, so that 6G will really become a convergent technology platform, and at the end of the day then represent the ultimate platform for the digital transformation of our society and economy, even more than 5G already is doing this and trying to do this, because it will be even broader and wider. And that's a big benefit by itself, because this way you can ensure that all the different building blocks fit very well together. And of course, we also then have completely different economies of scale compared to what we have currently if we look at all these building blocks here individually. And the last slide, and then I'm already done with a short overview here, is to just highlight a little bit now, again, key requirements and key drivers on a very abstract level. But I think we are in the early phase, so I hope that's still fair. So what matters with 6G, or some things that matters at least, is what I've outlined here, right? It's what we need is a high ease of use. It has to be very simple to use 6G, to operate 6G networks. If you look at the private networks, but also then these even smaller networks and so on. That was already and is already a topic for 5G, but with 6G that will be even more relevant. And what I also mentioned already, it's really key to have the costs and the benefit in mind from the very beginning. We need a solid return on invest at the end in a reasonable time. And therefore, we should not now focus just on technology and then see what does it cost at the end. But in all the discussions and so on, we should always have this in mind. So what does it cost and what is the benefit? Because in this B2B environment, and verticals are B2B, this is the only thing that matters at the end. And this can then, this adding new features with sensing and intelligence and so on helps to increase the return. But at the same time, we have to make sure that we lower the cost, for example, with the softwareization and so on. And then I'm very confident that it will become a major success. Of course, there are new frontiers, new use cases, especially these very localized networks and the maybe even some border use cases where 5G is not good enough yet. In industrial automation, maybe there are some applications where you need a latency below 1 millisecond. But I think the wide majority of things that we currently see at least can already be well addressed if 5G delivers on its full promise, right? So it's more than not just the quality of service improvements or improvements of KPIs, it's really these architectural things and so on, maybe which have a bigger impact in the future. Customization, I mentioned this because verticals are very heterogeneous. Even one vertical has many different requirements and settings. And also, of course, sustainability is a key aspect to consider, more important than ever before. We are still having the World Climate Conference in Glasgow, which reflects this very well. And now we can basically look at different building blocks here. Of course, it's not complete, just to give you a feeling of what we currently have in mind. So of course, 6G will be about faster, higher, further, high data rates, low latency, and so on, high reliability. Artificial intelligence certainly will play a very important role, both for optimizing the network, but also for offering this to use cases and applications. So that's really a key aspect. These localized networks, as I mentioned, even smaller network topologies, network structures, the softwareization, the developments towards higher frequencies, and also the integrated sensing capabilities. And if we then try, and also this is certainly not a finished exercise, right? But now we can try to map the different capabilities and so on, the building blocks that we have to the different requirements. And this is what it may look like. Certainly we may argue about every single line here. But what I would like to highlight is basically what I mentioned already. So this faster, higher, further certainly plays a certain role, especially for the new frontiers and new use cases. But there are other aspects like the localized networks or the softwareization and also the integrated sensing, which may drive more of these aspects, right? And which maybe have then a higher significance than just the better KPIs at the end. And that's basically, yeah, all what I wanted to share today. So to give you a little bit some insights in what we're currently thinking about. I hope it was interesting. Thanks a lot for having me. And with that, I give it back to you, Nancy.
Thank you, Andreas. Thank you very much. Very interesting presentation. I think we will come back with some questions later. So now I would like to introduce the next speaker. The next speaker is Klaus Schoenher. Klaus works in the Airbus defense and space industry. He's leading the German Space Systems program activities for Lasercom QKD, 5G and connected automated mobility. And he has served also as program manager for the European Data Relay System, the space segment. And he will introduce us to the Airbus view on non-terrestrial networks in 6G. We are looking forward to your speech, Klaus. Welcome.
Okay, Nancy, thanks a lot. Thanks for your kind introduction. Now let me try to share this. Can you see and hear me?
Yes, yes, perfect.
Okay, now next step comes presentation mode. Hopefully this works.
Perfect.
Okay, then dear organizing committee, dear chairpersons, dear one6G members, and everybody presenting, listening, discussing today. Those who know me know that I regularly enjoy working and discussing the 6G and in particular the non-terrestrial network subjects with many of you in our joint research projects or proposal work. And I'm always happy to give the Airbus view absolutely live and ad hoc with no PowerPoint slides, be it technical, economic, political, philosophical, it all matters. Now, a couple of weeks ago, Egon twisted my arm really hard and said I should give this speech on the non-terrestrial here, totally outside the ad hoc. So let me give it a try. So as you know, Airbus is a European transnational enterprise. We are a system integrator. We are a builder of high-tech platforms and orbiting platforms sold around the world. The non-terrestrial contribution to advanced communication ecosystems is, of course, a very natural Airbus playing field. It is our past, it is our present, it is our future. And it is what the market, what associated industry, academia, and governments actually expect from us. So why not have a look at this past, the present, the future, with the evolution from 4G through 5G to 6G and beyond. So here on the left, this is basically the silos, notably the non-terrestrial, the satellite silo, all competing silos with some interconnections increasing, but still with a lot of mistrust and discomfort and no history of joint achievement. 5G, this is where we are here in the middle. The paradigm change there has been the ongoing explicit inclusion of non-terrestrial networks, call it integration in flight, because non-terrestrial networks have not been there from the start. The 6G challenge in that respect shall be to consider space and airspace in the definition right from the start to help achieve a truly unified design. This unified design is the biggest challenge as seen by Airbus. So now, given the limited time, let me shed a light on the different dimensions that this unification challenge gives us. What is in it for Europe and how do we achieve? Now, Airbus, we expect systems of systems, networks of networks with a third dimension. So not just terrestrial, but a lot in different levels or in different layers, as you can see it here, responding to dynamic topology changes. Users and nodes, they are coming and going dynamically. By bringing in the best platforms, the best connections, the best capabilities available, and developing more by us and by others, focused on those which are most needed in the global competition. Thereby understanding the specific potential of all the space and airborne and terrestrial constituents, including regenerative space nodes in low Earth orbit and GEO. This chart here now looks a little bit more complex, and it shows how 6G can broaden the scope. And this is a way how Airbus expects the future, the three-dimensional future of these ecosystems to be, of such a dynamic multi-layer connectivity. We are sure that Europe can stand up to the worldwide competition on connectivity solutions towards the competition from the other continents, basically. And if I mean Europe, I mean tectonic Europe, including UK, including Switzerland. This is not a European Commission exclusive thing. Delivering such connectivity solutions requires a good match of the three pillars which you see on this chart: the network management and orchestration part, the communication protocols which shall fit to this, and the space and ground nodes design, who in these parts shall be using both RF and optical comms technology, meaning laser comm, which is my personal history, benefiting from artificial intelligence and machine learning and security, both in the technology and also serving their needs. And also solving the connectivity and the cloud and multi-access edge computing challenge in combination. In order to achieve, we need to embrace fair and constructive competition in the technology, in the engineering, in the operations, whatever, and the momentum that such competition can bring. In the end, the reality, this is our expectation, will reward the best fits to the needs with bigger shares than others. And it will reward European customers, European providers and governments, etc., always more if the key stakeholders complement and amplify each other's strengths and deliver solutions that are fantastic. And it will reward the consortia with changing purpose-driven composition, and this is what we do, and not so much cartels where everybody wants to be in, or solid clans, which will never change and adapt, and which will weaken Europe and its nations. Already now, we need to think out of this box, even out of the 6G box, and think operability with what is beyond 5G and 6G, like the European data sovereignty by Gaia-X, the Euro QCI quantum key distribution, which is a three-dimensional topic, the three-dimensional terabits laser comm network Hydron, which we are working together with ESA at the moment, or, for example, the European Secure Space Connectivity System from the European Commission. We have to be open to all of them, including even those which are not even invented yet. And now comes a more difficult part. We need to push for the terrestrial and the NTN stakeholders to cooperate in research and in demos to build trust on joint success. There is no such history. We're just starting a bit, and we still need to make this history. It's not going to be easy. We heard Uwe Löwenstein this morning from the ITU. The radio regulation competition rituals between the satellites and the terrestrials are well known. They will be difficult to abandon and to redirect to a proper win-win attitude. We need to involve politics, local politics, national politics, European politics, to help them change and adapt and be part of the solution. And many of them still need to embrace the non-terrestrial. They don't know where we are. They need to create and adapt roles and regulatory environment to help Europe achieve and make Europe sustainably the best place to live. And a little message, last message from those who were in the Kairos campaign. One lesson learned from there still prevails. Merging the consumer and the provider roles into prosumers in an organized way to make best use of shared resources where they choose to go, rather than where we plan them to be. This may sound soft because this is very much about relationships, but it is not. It can't get any harder. So let us try, nothing less. Let's face the challenge together. I hope this was a useful compliment to the wealth of all the other speeches before. Thank you for your attention, and let me have your questions. Thanks.
Thank you so much, Klaus. So since you are the last, maybe I can start with you with the questions. We have one question regarding the services that Airbus targets in the 6G timeframe. Which ones would you prioritize as potential services for Airbus and 6G?
So let's say one type of service that my colleagues from the Connected Intelligence are explicitly in are, of course, lasercom relay services. But this is, for the moment, not necessarily related to 5G or 6G. But we are sure that in the end, let's say the differences between, say, 5G, 6G, and lasercom will disappear. They will all be part of the same ecosystem. It will be a challenge for my Connected Intelligence Service colleagues to actually find their role in all of this. So being operators of space parts of systems is always something that we will do. Competing with large non-terrestrial, with large terrestrial MNOs is more an unlikely area that we will be entering. But we will be probably taking ownership of the parts which are less comfortable for the terrestrial operators to deal with.
Okay.
Hope this
Thank
helps.
You. I have one more, I think, but I think it's similar. Okay, the second question, Klaus, is about the challenges, the kind of challenges you would foresee for the integration of non-terrestrial and 6G mainstream telecommunications systems.
I think the chart, which is still on, I think it shows that the challenges are in each of the three pillars and in making the three pillars actually work together. What I mentioned is this non-established history of trusted working together with mobile network operators and the space community, which is a non-technical thing. We need to resolve it by solving technical issues together and building this relationship. I think this is a huge challenge, and this is what my colleagues and I have been dealing with since years, and we are trying to change that.
Okay.
Building opportunities to do it.
Yeah, thank you so much. We have a question as well, two questions, I think, also for the health sector, for Professor Tümmler. The question is that the question says, I see that you have listed quality of service management on 5G e-health SACs in slide 9. Do you oversee special quality of service requirements management in this context, other than the support of more stringent KPIs?
Yeah, I read the question before. I mean, this is a very general question. I mean, of course, there's tons of quality of service requirements in the health domain with respects to 5G, and depending how 6G will be structured, there might be even more. The question is, I mean, and these obviously, you know, these quality of service requirements, they go beyond the quality of service requirements that you can find in some kind of standardization reports, because the standardization reports is a generalization, and they say, well, we should have a latency of not more than 1 millisecond and so on. But in the health domain, the quality of service requirements, they're also resulting from legal requirements, you know, which we have to observe. For example, that content cannot be shared in a certain way, and it must be safe. So it's all about data protection. And on the other hand, we have quality requirements that come from the specifications of the medical devices. We must prevent any interference and so forth. So there's a huge array. And we cannot discuss all of them, you know. So if there's a specific question, then I can answer, but this is too wide.
Yeah. And there is another question, but I think you mentioned something in your presentation about you know, the post-COVID era and how you see the issue, or in order to bring together or closer the 3GPP standardization with the health sector for the 6G system.
Yeah, I think this is a very, very general issue about the relevance of 3GPP, or the core competency, I should maybe say, the core competency of 3GPP in the future. I mean, we make the experience, and I think what I said just refers a little bit to that. 3GPP can not regulate anything in all of the verticals. That's impossible, yeah? And the more intelligence, as Andreas showed these diagrams, you know, the more intelligence you get into the platform, and the more this platform becomes a platform for everything, you know, so everything as a service, everything, yeah. The more there will be requirements for further regulations that are outside 3GPP. So we have to think about some kind of extension to the 3GPP. As I said, you know, the requirements, for example, that result from medical product regulations, or from rules and regulations that we see with the medical devices, and the requirements of 3GPP, they have in one way or the other to merge. We cannot have it top down, you know. We have to somehow also have some kind of a bottom-up strategy. And then we have to get to standardizations that cover, on the one hand, the telecommunication standards resulting from 3GPP, and on the other hand, the standards that are coming straight from the verticals.
Mm-hmm. And there is also a similar question to Andreas Müller. I think if Andreas can make also a comment about the issue or the challenges related to the standardization with the issue of how to extend the participation of the verticals in 3GPP?
Yeah, thanks. And it's also a very good question always. And I'm not in this presentation, but in other talks I already mentioned this, so that I think we really have to rethink also the way 3GPP works, and how in order to achieve basically the goal that everybody's interested in, right, to get more vertical engagement. Also the existing players are asking for that, but without changing the way it works, I'm not so confident that we will see a significant change here. Of course, there are big players, Bosch is one of them, others also, which are now having a footprint in 3GPP, but still a small one compared to many others. And I think the way 3GPP works, right, this is because it has been designed for the classical business model, for the classical case that I outlined in my presentation, which is deploying a nationwide network, building a network for the consumer industry, for the end consumer, basically. But now with all the verticals and so on, it's much more diverse. And if 3GPP did not exist today yet, right, maybe, or not maybe, but very likely we would design it in a very different way. And I think somehow now changing it radically, of course, is also difficult because, I mean, this has also been maturing over the time, and there are good reasons why things are the way they are, but at least we have to see where can we maybe change a little bit towards this direction, so that it's really getting easier and simpler for verticals to get directly engaged. I really think that's necessary. Just telling verticals how 3GPP works as it is done right now, this is already good, but it doesn't solve the main problem. And the verticals, of course, for them, 5G and in the future also 6G is always just a fraction of their business. It's one building block, apart from many others that they have to consider, and therefore they cannot send dozens of people to 3GPP. So therefore we really have to rethink the way we are doing things here. But I would also agree with Christoph, so 3GPP certainly will play an important role also with 6G, but there will be other organizations as well that need to be considered. And to what extent, I think that's something that we will see in the coming years.
Okay, thank you so much. I have a similar question to both Marius and Antonio for the automotive sector. Since the automotive sector has been heavily involved in the 5G specification, what would be the use case that you would see fit for a 6G system? What would be the gap or the requirement for a 6G system? Maybe Marius and Antonio, you can make a comment on that.
Yeah, I think somebody has already written this question in the chat somehow. So of course, 5G will fulfill some of the requirements, but we, as I have shown to you, when we really expect the autonomous driving, and we are talking about shifting compute power from the vehicle to the back end, then we rely on a constant, stable data rate, uplink data rate for many vehicles at the same time. If 5G or maybe the further versions of 5G will fulfill these requirements, then everything is okay. But we have the impression that we will need some further developments here, and these might lead to 6G, or that also allows us the combination of terrestrial and non-terrestrial communication.